The Duke University Superfund Research Center is focused on early life exposures to environmental chemicals and their consequences later in life. Our top-flight investigators and trainees are committed to understanding the complex and dynamic landscape of environmental health. Their innovative approaches and unique personal research stories shape the rich landscape of our work.
My name is Savannah Volkoff. I'm a Ph.D. student working with Dr. Claudia Gunch, and I'm also a Superfund trainee in the Duke Superfund Research Center. I started as an intern in the Duke SRC in 2013, and I began working with the Research Translation Corps. And after that internship, I was hired full-time to continue my work in the RTC, as well as work with the Nicholas School of the Environment's Ecotox graduate program. I initially pursued science because I wanted a better foundational understanding of the risks associated with chemical pollution and exposure to communities, because I felt like I couldn't be a good advocate without having a strong fundamental understanding of the science. And so in thinking about my path, I always wanted to pursue science with application, something that was tangible to people and that people quickly understood the value of, and knew that there was a purpose for that work. And so I think while my background and my path to science is definitely non-traditional, I think it has served me well to always keep perspective about the work that I'm doing. In Dr. Gunch's lab, I study bioremediation, which utilizes microorganisms like bacteria and fungi to clean up polluted sites. So we're working at a site in the Elizabeth River, which is polluted with creosote. And the primary chemicals in creosote are PAHs. And so for my dissertation, I was focused on identifying bacteria from a specific site in the Elizabeth River that's capable of degrading that type of pollution. The current strategies for remediating sediments include dredging and capping, which are really expensive and invasive technologies for the ecosystem. And so bioremediation is an approach that is more cost-effective and potentially more sustainable treatment approach for these types of environments. So the overarching goal of my PhD was to develop a bioaugmentation strategy for the Republic creosoting site. And to do that, we isolated pH-degrading bacteria from sediment and then coordinated them within a biofilm. And then finally, we used a activated carbon-based pellet composite amendment that was produced by Dr. Paul Zizzo at the University of Maryland in Baltimore County to actually deploy the biofilm structure. So I met Dr. Paul Zizzo at a poster presentation at the Superfund annual meeting a couple years ago in Philadelphia. And he had some interesting suggestions for my work and had invited me to collaborate with him at some point in my PhD. And so when the K.C. Donnelly externship award applications came available, I remembered Dr. Zizo's proposition and had continued following his work and thought it would be a good way to apply our biofilms to the Republic site. And so we applied together for that award and received it, and I was able to utilize that technology for my work. The organisms that we're using in this work did come from the Republic site sediments, but they have been identified in other sediments that are contaminated with PAHs. But the methodology that we utilize, the strategy of isolating bacteria and then coordinating them within a biofilm for bioremediation can be applied at other sites with different types of contaminants and different organisms. So the methodology can definitely be applied elsewhere. I have always really liked the collaborative and interdisciplinary nature of Duke University, but especially the Superfund Research Program. And I know that my research has definitely been improved by the input and supportive and collaborative nature of this environment. So I will be joining an environmental consulting firm after my graduation to continue working with polluted sites in North Carolina and focusing on their remediation, specifically with sediment and soil sites.